Some NEC PVC-740 goodness. Let's crack on. Hello and welcome to another MrBetaByte video, and this one's a little bit different insofar as we're looking at an NEC PVC-740 Betamax machine, or beta machine. And this machine is in great cosmetic condition. It's lovely. It also comes with the operating instructions and ready reference, which is really quite cool. Sort of has tips and tricks and just basic quick start type stuff. When you get it out the box and you're all excited and you want to get it going. And it also comes with all of these numbers, which you can change for the channels. And it's really cool, to be fair, to see this sheet. They always got lost. So that's really cool. And we also have the wired remote, and just like some of the Sony machines at the time, you do literally just get pause and picture search. So it's just really for the convenience of not having to be at the machine to just skip forward and backwards and pause as well. So yeah, it's quite cool. So what I'm going to do first is actually take the covers off, and or take the top cover off anyway, and just see what it's like, see what condition the battery's in, if the battery is indeed still in there, and then we'll give it a test and see how it performs. Let's crack on. So I have to say, I don't remember these having screws at the front. I always thought they had screws, just those two at the back, but maybe this is an earlier model. I don't know. Gonna have to check back. We have looked at one of these on the channel before, actually. I might put a card up and a link if I remember to do it. But yeah, I don't remember there being all these screws, and you know, they look to have seen life. But yeah, let's get those out and take the top off and see what we're up against. So top covers off, and interesting choice of screws, very reminiscent of the C7 and C5, but a lot shorter than their machine screws as well, so they're going into metal inserts into the plastic, which is quite nice, I suppose. We've got the usual mains right close to where you might put a hand if you weren't careful, but the actual machine looks really very good. I mean, it could do with a bit of a clean. Definitely it's quite dusty, but wear wise it looks pretty good. Now this deck, it's again very reminiscent of a Sony C5, C7, but it does have a difference. It's more like the SL3000, this deck, and it is a Sony deck, of course, just because it's got the lacing arrangement like this, which is exactly the same as the SL3000, sort of portable unit, if you want to call it that. So yeah, that's actually quite cool. Certainly does need a jolly good clean. Belts wise, we're looking pretty good. Apparently this does have the belts changed, so but we'll check that. Battery wise, I think it's this board that has the battery, the backup battery on, and I can't actually see a battery. So I may well whip this out and we'll just check. So not pressing hard enough. don't like doing that. I should be able to lift this out, to be honest. Shouldn't be too painful to do, he says. There we go. Yeah, so the boards are out because we've got all of that to deal with, but the battery has been removed and actually looks really pretty clean, to be honest. The last one I had, the board was a bit, well, quite a bit more damaged than this, but yeah, that's really cool. So I'll put this back in and we'll crack on. Bit of an interesting one here. You can see, well, I don't know if we can quite see, there's a black connector down there, and yeah, the connector that should go on it is white, but what they've done is just put a black permanent mark on it. It's just, that's actually really cool. So yeah, I thought it was quite fun. The other slight problem we have is these tabs. They're just sort of bent back a little bit. So what I will do is just pad these out a little bit against the plastic at the back, just so they spring back. I'll probably use some. I've got some foam standoffs actually. I could probably use to just do that, just to give them a little bit of a bit more springiness than they have. So yeah, you can just see it doesn't quite. Well, it doesn't really latch at all. Very common problem. These usually got broken off, to be honest. But yeah, and of course all the buttons are bad. They use the same buttons as the C7, so they're going to have to be changed. Okay, so let's put that on bright. So I'm thinking now, let's give it a test. So these do use a switch mode power supply. Generally pretty solid, to be honest, but you never know. It is quite old. So let's power it on. That's looking pretty good. I'm guessing we can't set the clock because the buttons are just too far gone. Yeah, it's too far gone. Okay. Turn it on. We have no eject. And we have, oh, it's online. Okay, that's cool. So that's fine. Yeah, I know I'm continually pressing this, but it's just, is there a problem with the button? I wouldn't have thought there is, because these tactile switches are usually really good. But yeah, in this case, okay, so we do have quite an issue going on here. I'm not sure, is the stop button supposed to be illuminated, or is that just when the cassette's in? Yeah, so when the cassette's in, the stop button illuminates. So let's just Dies with death. Winding this on. I do wonder if we've got a power supply rail missing. So if I now press that in, what does it make of that? Nothing. Going to record, of course. I think we've got a power supply rail missing. Okay. Well, that's disappointing. Yeah, I thought this is a working, well, pretty much a working machine, but obviously it is not. Right, okay, I suppose we ought to do some checks. Let's crack on. Well, this is a bit odd. Suddenly, it works. That is something we'll have to look at. Well, I'm going to call it a night, so we'll try it in the morning. Let's crack on. I have to say I'm not convinced that clock's working as it should. But yeah, let's try a cassette. Oh. Yeah, we still have issues. It's a bit weird. There is something that's sort of in the back of my mind with this. I'm doing this just because I wonder if it is something to do with the switch underneath the dicing with death. So let's press eject. So it knows it drives. So I think we have a mechanical issue. Ooh. Quite funny, there's a black connector and a white socket. It's like if they'd swapped those over with one on there, that would have been fine. Okay. Ooh. So yeah, it's still not lacing. What's that sound? Do we have... Oh, well... This is weird. Interesting. So the machine hasn't been on for about 24 hours now. What I'm wondering is if there is a power supply issue, like a capacitor that's sort of taking a while to sort of, if you like, work due to age. So, like I say, it's been off. Let's just try it and just see if we can eject the tape. So, I'm still not convinced that clock's right. No, it's not right, is it? Yeah, you see I get nothing. And I bet if I leave this on, things will start working. So I've probably got the higher voltages working, but I don't think the 12 volts is working quite as it should, maybe. I'm guessing that's a 5-volt rail. I haven't got a manual for this either, and I've tried to look for one, and I can't find one. So, yeah, I'm not even getting you can hear a relay clicking. You know, and it's trying to work. That clock going off is not a great sign. I wonder if that was on, why it was on dim. Let's just try. Again. Yeah, see, it just goes straight off. This goes off as well. So I'm fairly confident we have a 12-volt power supply rail issue. And I'm assuming it's a 12-volt power supply rail that's bad. It might not be. There's a tab missing off one of the connectors. I think this machine has seen a little bit of servicing life. But yeah, I mean, I do like in many ways switch mode power supplies, but they can be a bit of a pain in the neck when they go wrong. Especially if you don't have the service manual. So, I mean, this is going to be an interesting one because I do rely quite heavily these days on service manuals, and I never used to. I used to just wing it. And I've just got used to having the service manual there. So, yeah, could be a fun one, this. Let's crack on. So just looking at the voltages on the clock. So this connector goes straight to the power supply. I think that on the yellow wire should be 12, and this one I think should be 9. I think there's a 9-volt rail on these. I don't know why I'm remembering that. Might be wrong, but they're low. So I'm pretty confident. We've got a minus 18 volts, which also seems a bit low. I do seem to remember that possibly these should be about minus 26 volts, but I could be wrong. I suppose I could look in the Sony C7 manual because that would give me a clue. It's sort of vaguely similar, so maybe that's the way forward. On the red wire, which I would have expected to have a rail on, there's nothing at all. And the brown wire, nothing at all. So yeah, but the clock, I'm sure the clock should be effectively ticking, should be working, and it's not. Just like on the C7, you know, C5, it'll the center digits should be doing something, and we should be getting a counting up, but I could be wrong. because I know some machines didn't do that. They didn't count the minutes from when the machine had been turned on. They just stayed at 0. So yeah, I think I need to get this power supply out, and yeah, let's have a look. Probably not the best solution. I was going to put some sort of I was going to put those double-sided sticky pads that I use for replacing the black pads and HF950s in there, but I couldn't find them, so I ended up, you probably might just be able to see, just putting a little bit of hot glue in and just trimming off, which I haven't done particularly well there, any stray bits, because that's what it does. It does now feel positive, so I'm fairly happy with that. The tabs just get sort of bent back over time, and they are so fragile. I mean, honestly, just need to trim that one a bit. But it's locking, so I'm happy with that. Just wondering if that might. Yeah, it's only got 10.3 volts. I'm sure that's not right. I was going up a tiny bit. But what I'm going to do is actually leave this on for sort of a few minutes and then come back to it to see what voltages we're getting and whether we can actually eject. It's still behaving the same way and not really doing anything. But yeah, let's see how we go. Well, I've checked those voltages, and I mean, still got no eject, and they've not really gone up at all. So my plan is to remove the power supply. There's a bit of warmth there. I don't know why that's important, but there is a bit of warmth there. So 2 screws there, 2 screws at the back. Obviously unplug stuff, take the strap off, and it'll be out, and we'll take a look. So I'll get and do that, and yeah, see what's going on. So power supply's out. Obviously you removed the 1 screw already. Because of that grounding strap. I don't think I've ever taken one of these apart. It's probably testament to maybe these being very good power supplies generally. Oh, screw's gone in there. Well done. Let's grab that. So we've got 2 screws at the bottom here. It's actually quite fun to work on something without a manual. To see what we can do. Manuals do make such a difference. It's made life a lot easier, especially as I don't have a huge amount of time these days. So I'm not sure if this has bleed resistors to take any surplus voltage from the primary side. Loads of caps, which could well be what we're looking at. There's a splatter of solder there. Let's see what's on those primary side caps. Yes, they're discharged. That one isn't. So why is that one? Oh no, there we go. What are these like? 93 volts. Let's actually do that the right way. 33 volts. So yeah, so there's some buzzy stuff going on there. Check this one. Yeah, that one's no, discharged. So yeah, something to definitely bear in mind. There's no bleed resistor on these, not like Sony stuff. You've got to give it to Sony. They really do do a good job on these caps. That looks to have been changed, and possibly that one too. So yeah, it's been worked on. I do wonder, maybe not. I just find it odd that there's a splatter of solder on there. Yeah, interesting. But I'm guessing it's going to be one of these caps on the secondary side that is bad, and possibly become a bit of a resistor, loading down the rail as well as sort of not smoothing it that well. But yeah, I've got quite a few to go at. So yeah. And there's a rather hefty resistor there right by one, which is never a good good thing. Taking it apart, 2 screws there to get the heat sink off from the board, but then you have to remove the heat sinks here, which is not too bad, to be fair. So yeah, cool. Okay, so let's just charge them. There you go. That's why you don't want to do the put your fingers across that. Still 32 volts there. I'm just really surprised how bad these are for not having a bleed resistor. So let's just do that again. There we go. So that's now discharged. Blimey, made quite a mark there. Didn't mean to do that. God, that really did so much energy. Yeah, I used to have actually a special, if you like, screwdriver that I'd had a bleed resistor on it, just so, because I don't really like doing it. It's still 9 volts across there, because it can actually damage the caps. The shock of discharging that quickly can cause problems. But well, yeah, we've done it, and yeah, it was fun, wasn't it? So let's get this heatsink off. entry stuck. Did I manage to break? Yeah, I did. But that's fine because I can just put it on in a slightly different fashion. It's a little bit ripe. There's the hole. So I'll just put it the other way round and that'll be fine. So I suppose we ought to see, oh, that cap there looks a bit swollen actually. Maybe, I mean it's got a stamp in the top of it which could be a bit deceptive, but yeah. Time to do some recapping, I think. So yeah, let's crack on. Well, it's a couple of days on, and I've pretty much changed all the small caps, but I had to wait for two to come. I managed to get through 50 of these 10 microfarad 50 volt caps and ran out. So I had to wait for some more to arrive, and just fitted those, and we are looking good. I've checked all of them, so all of these larger ones test absolutely fine. Replaced that one because it was showing a little bit of signs of sweating. These two were pretty bad. These are the 4.7350 volts, same as the Sony power supplies of the time. So yeah, they certainly needed to be done. Reservoir capacitors we know are good because of when we sorted them out, but yeah, they're fine anyway. So yeah, I'm going to reassemble it in the hope that I have actually sorted it just by doing those caps, but I will check some of these as well. You can see the leakage once it's all back together, and to see how bad they were. Let's crack on. Well, I just spotted something. Just sort of repositioning this lead, and this wire is actually broken. So yeah, I'm going to have to do something about that. But I wonder if that could have been part of the issue, or whether it just came out when I pulled it out. But you know, maybe it's just been floating about in there, and it's certainly not been pulled that hard, and not been pulled by the cables either. So yeah, because you could just about get... Oh, maybe I did try and get purchase on there. Yeah, it might have been me, because it was quite tight in there. Let's just see what that looks like. Now I can quite easily just pull that out. It's yeah, it's a bit stiff, but yeah, I would have pulled that out by the plug. Yeah, those really heavy duty plugs, you've got to really pull them out by the plastic, because the cables aren't as strong as the actual connector installation itself. So yeah, but anyway, I'll figure out a way of fixing that. After a bit of head scratching, I eventually managed to get the one part of the plug out, and it was a bit tricky. Basically, I used an Allen key. What size was it? I think it was a 0.9 mil Allen key in the bottom, in the little hole there, and just sort of wiggled it about, pushing, so it went sort of that way, pushing this locking tab there in, and then it slid out. It was actually not too difficult. Now I've just resprung it. I've soldered an extra bit of wire on, just so it relieves a bit of strain there, because it was pretty broken. And then twisted, soldered, put some heat shrink with glue in it, so it's good and solid. That ain't going anywhere. This is actually one of the 12 volt rails. It looks to be 12 volts ground, 12 volt ground, and these two are actually shorted together, so I'm a bit confused how this is done. But on this power panel here, those two split rails are on different fuses, so they're separate but they're not. And on the power supply there's a capacitor, a dedicated capacitor for each, but then there's all the three 2200 capacitors as well. Unless I've worked that out wrong. Like I say, I haven't got a circuit diagram or service manual, so I could well be wrong. But yeah, I can't quite get my head around the design choices there. I did wonder if maybe I was missing something about a switched. One of them switched, but I can't see how that's even so. But anyway, I put it back together and put the machine back together, and we can give it a test. I thought I'd try and sort out these buttons, which are completely and utterly dead. Door's still working pretty well. So I literally just lift it off because it's already unscrewed. So it's very, very tidy, this. And I seem to remember it's just putting these out and you're good to go. So they're just these little retaining clips, and centre pin pulls out. And I need to give that a bit of a clean, but that's fine. Is that it? Doesn't feel like it. That should come free. Do I have to lift it up maybe? Or is there... It feels like there's something under there. Yeah, there's another one. I know I've done this once before, so yeah, that's just remembering. It's been a while. So, under there, the remaining one. I will say the repairability of these NEC units is maybe not that great. I think the power supply was very much, if it did fail, you got a whole replacement unit rather than repaired it as such. But I noticed there were two variable resistors for voltage adjustments, and it just says RV1, RV2. That's it. And it's just, you know, there's no voltages labelled anywhere. You just really don't have a clue what's going on at all. At least with Sony stuff you do get that. I am missing something in doing this. It feels like that clock unit should come off, but like the whole lot. I've done this before as well, that's the thing. I just thought you lifted this up and it popped out. Yeah, no, it doesn't have space. There is a screw. There's a screw directly behind here, which might help things. I don't believe it will much, because there's probably going to be a second one or more than one. So it's taking this off, it's just sort of move to one side, then start lifting it up, and then move to the other side, and that's released it. But I can't get it out because it's trapped behind that board. So that must be right. There we go. I'm sure that's not the right way. Oh, I've just found the other screw actually to take that assembly out. So down in here behind all the loom is another screw, quite hidden. Does that? Yeah, that releases it. That would have got me out of trouble. So yeah. Oh, I do vaguely remember doing that as well. Now, better late than never. So yeah, let's get these buttons swapped over. So just looking at the difference between the Sony C7 switches and the NEC switches used here. So looking at the difference between the NEC switches and the Sony C7 switches, you can see there is a difference because they're both collapsed in the height, and same manufacturer, Toko, but the type is 331 on the NEC and 330 for the C7 and C5. So this could be interesting. Also got folded over contacts, which can be a bit fun to free up, but yeah, I'm just going to use solder braid on that. I'm not going to use a solder gun because it's a bit pointless really. So yeah, I'll get that done now. We're struggling a bit with these switches. Even the 2-pin ones that I used on the C7, they're not long enough. These are just that little bit longer again. So I came up with the idea of using these really quite short throw or short button switches, tact switches, chopping off the top of the switch, gluing the tact on top of the, it does spread the legs out on it a bit, gluing that on, and then I'll use some fine wire just to connect from there to that pin and there to that pin. So I think, I mean, it's, you could argue it's quite bodgy, but on the other hand, it's actually quite cool because it should have about the same travel. So this is actually depressed. They're all frozen in the depressed position, and let's just get that so it's the right height. I think we might get away with that, maybe. So I'm going to give it a go. Nothing we need to lose. I haven't got any other switches that are suitable. I've got a pack of switches, and the longest one is still not quite long enough. It would be all right for a C7, but not right for this. Just that tiny bit longer. So I'll do that, and we'll crack on. Yeah, it's quite fun sort of taking the tops off. So let's use a scalpel, and I am just literally chopping them off, and then you get that hole. And yeah, sort of quite tidy really. But yeah, let's crack on. So they're all done, bar one, which I've just finished off doing. So literally glued on the top, legs spread slightly to sort of straddle the original switch. Obviously cut off the whites, and use some very thin copper wire just to sort of connect it up to the original pins, and then with a bit of heat on there, because the solder does sort of stop the switch going cleanly in, so you just have to sort of melt it as you push it in. Yeah, it's not too bad. I mean, I still have a concern that, I mean, these are the shortest button depth that I have. I know you can get them almost completely flat, which might be a better thing, but I'm just a bit concerned that these are still going to be too tall, and I'm going to end up having to file off the tops of these things again. Like I had to chop off the tops on the C7. But anyway, I'll put this in, put it back together, and I suppose give it a test. Moment of truth. Let's put this on and see if my worst fears have been realised, that those switches are probably a bit too big. No. Oh, that one's a bit. So there's a couple. Yeah, they're not quite. I would say I've not soldered them flush to the board, maybe. Quite as flush as they should be. But they look okay actually. Let's just try that again. There we go. Yeah, it's just those two. The other ones are fine. So 1, 2, 3, 4, 5. Super. I'll get that sorted now. Much better. So if I really push this, I mean, this is past really where it needs to be, but they're all better. I actually took the board back out. I just melted the solder and made sure these weren't rocking. They were totally flush. Because I'd wrapped the wire around the legs, it was causing them to mechanically not go back flush as they should have. But the other thing I did wrong, down here there is a little groove that the board needs to sit in, and I located it in front of that. It wasn't in it, so that was sort of pushing the board out, and that's why the front wasn't fitting very well. But yeah, we're all good to go. So I put the front cover back on, and I suppose we're going to give it a power on test. Let's crack on. So I'm going to put the front cover back on, and we'll give it a power on test. Let's crack on. So here we go, power on test. Well, it's on. It's not lacing up though. So we still have issues. Ah, interesting. So I think the power supply is working. Can we set the clock? Clock set. Day. Yeah, it's giving up. Wonder if the loading motor's jammed. I don't seem to have any center digits either. So I'm just wondering if that clock is actually going to tick. Oh yeah, I can very faintly see. I mean, there's obviously some damage to the clock board from that battery. I don't know whether you can see that. Yeah, I don't know whether you can quite make out the bottom digit in the middle there. It's just showing a little bit of like a tick, like flashing there, but it's working. Just need to investigate why we're not getting those particular segments. But I wouldn't be surprised if we've got a jammed Capstan motor, so we'll have to have a look at that. Let's crack on. Let's have a look at that Capstan motor. So it's pretty clean. There's some dubious detritus there. What that is, looks like food. But yeah, let's lift this board and have a look at the motor. So the motor's actually fine, which is a bit disconcerting, a bit worrying. I'm not enjoying this at all. And this belt is maybe not great. It should be okay, but I will try and find some belts for this. Yeah, I'm gonna replace this because this is horrible. Now I'll just solder the leads together and put some heat shrink on it. Could really do with a belt kit, really. There's some muck on that pulley. Of course, I mean, I'm being daft here because I'm thinking of this as the same as the C7, and it's not. and the C5. This has a separate loading or lacing motor, and I just wonder if that is possibly what's causing us the problems. Yeah, I think what I'll do, I'll get this sorted, try and find... Oh, this belt actually isn't too bad, but I'll give everything a clean. Clean off the... Yeah, there's debris from an old belt there, melted belt. But this needs to go. This needs to be replaced because it's just not good. So I'll do that, and we'll crack on. Not proud of it, but I put the old belt back on. I just cannot find a belt that is this size. And I will take some measurements off it and get them over to Star Components, because they have said they will try and create a belt kit for the NEC PVC-740, which would be great. So yeah, I'll take some measurements. This is the same as a C7, so that's fine. Again, it's not great. I mean, I've cleaned it, but yeah, I'm not overly impressed with that belt. It is the original belt as well. It's got the white mark on it there. But I suppose if we can get the machine working and give it a test and see just how those belts actually perform. But I think this has all original belts, and I thought this actually had the belts replaced, so yeah, that's not ideal. But yeah, let's crack on. I found a belt. It's actually out of a MV 250-450 belt kit. So VHS of course, but some tyres in there as well, which might be useful. So it's such an odd size or length, diameter. Things are either too big or too small, and of course you need the thickness as well, because there's a heck of a lot of torque on here. So yeah, I'm really lucky I found that. Still quite pleased with that. I'm going to change the Capstan belt as well. That is exactly the same as a Sony. I've actually got a PVC-740 belt kit, so I'm going to take the belt from that and yeah, just use that one. Yeah, so the capstan's pretty grubby. I don't think these have the washers on the shaft on the other side, sort of the dust washers. So yeah, I can just pull that straight out and give it a clean. It looks like there's spacers in there. Yeah, sort of interesting to see the difference between this and the Sony. It's all cleaned up and good to go. Nice and shiny. Bit of tight fit by the head drum motor there. So let's put this new belt on. Should be fine. Then we'll see about this lacing issue, and yeah, I've got a theory on that one from a previous video I did actually on these machines. Oh, I've done that really badly, haven't I? There we go. It's all good. Super. Drop the cover back down, or drop the cover, drop the board back down, give that a clean, and yeah, let's crack on with the top of the deck. Okay, so here it goes. Put some power on it, and doesn't even make an attempt. I mean, there's a good belt on there. I was sort of wondering if maybe, yeah, it goes onto this panel immediately beside it, but this is where I could really do with a manual and see what the logic process to all of this is. Ooh. Let's just try to unlace. I'm just winding this on. Right, okay. It obviously knows when there's a cassette in there, because if I press the tape in, it's saying stop, so it knows there's a cassette down, but that means that somewhere stick my finger in there without killing myself. Just wondering what actuates that. Just wondering if there's a switch that's not being triggered somewhere. I don't quite see what even activates that. I'll no doubt work that out as we go along. We can't really see any switches in there. I've got a couple of idlers, which I think we can probably do something with. Yeah, it's got an idler motor, of course. Seems to be quite a lot of grease all around here. I wonder if that was a bit of an attempt to try and get things moving, thinking the motor's getting jammed, but it's not. It's absolutely fine. It is a logic problem, I think, and probably a mechanically induced one. I just can't see what else it could be. Like a switch that isn't being pressed, or So as soon as I release that, it will try and unlace. Yeah, interesting. We're a couple of days on, and quite a lot's happened. But with this machine, I'm just testing the Darlington transistor, and that is coming up as a diode. And what appears to have happened is this is basically completely open circuit between 1 and 2. So it just popped. Now, when I tested it, the whatever it was, 2SB something, that actually tested weird. But I found out that when the battery goes really low on these, they can get a bit confused and come up with all sorts. So with a fully charged battery, comparing the two other transistors, they're exactly the same, so that's great. So I ended up just changing one driver transistor, which is great. And the other thing I've done is I've liberated a new socket off a Sony C7 board. Board's actually turned out to be very, very useful. I've liberated quite a few parts off that, and so that is now perfect. Let's see, 4 devices are in, so all good to go. Managed to get this back in. It is a fiddle working on this panel, definitely. It's not that easy to get out, get access to. I think you're supposed to really take the power supply out to really get full access. Take the power supply out and sort of turn it over somehow, or lie it across here, so you can run it with this board sort of accessible. But yeah, that's fine. Put the top loading system back in and aligned it so to get the spools so they sit properly when the basket is down, tray is down. So yeah, I suppose we ought to give it a try to see if that's all it was. I'm sort of keeping my fingers crossed. And it is one of those things where as far as I'm concerned, it's working, even though I haven't powered it on. And powering it on will be the test. But anyway, let's try it. Oh, well, that's not a good start. I've probably missed something, haven't I? I do wonder. I think there was something on there. Put the one on the back, and I've put the one down there. There's one right the way at the bottom there. I'm just wondering if, in all the confusion of cables and things in the way, I actually missed a connector. I think I will have a look at the video I did in the last segment and compare. Then we can take it from there. Found it. It was actually trapped underneath the head amp can, and yeah, and it had got all sort of out of the routing as well, because I had to undo this, and it got the wrong side of this, and it was just, oh yeah, just gone completely wrong. So yeah, let's give it a test. So here goes, power on. That's a bit better. Yeah, little plume of smoke. I don't know whether you saw that. Yeah, and it's shut down as well. Not sure what's happening to the... Oh, it's semi-loaded, semi-laced. Yeah, so do we have a motor issue, or do we have something else? I'm assuming that's probably popped again now. which is a bit of a pain. It's just a bit weird because it laced a little bit. And unlace is fine. So I wonder if maybe I do have a problem with the driver transistor as well. Because I don't really want to, well, I suppose lift the board up and, oh, gosh. I mean, I probably can get away with not lifting this out completely and taking everything off, because I know it is just literally just behind here. So let's do that. New one's out. Let's give it a test. It's actually looking okay. I wonder if it's worth me changing the driver for that as well, even though it tests okay. Maybe that might be a good idea, just in case. I mean, I'm just using this tester, and when I try it with a multimeter, you know, it doesn't necessarily mean it's fully working. So yeah, I think I'll try that and take it from there. Let's crack on. And testing, yeah, that's not looking good, is it? It's become 2 resistors. Okay, well, this was testing okay earlier. Maybe, I don't know what's going on, because this is what I was originally getting, was just like weird sort of settings from it, but results rather from it. But yeah, I'm sure, yeah, when I originally tested it, it was, both were bad. I mean, this was hot, but it seems okay. Not sure where that plume of smoke came from. Maybe it was from that. Was only like a little puff of smoke, but it doesn't look like it's compromised. Did we zap a resistor or something? I can't see any burns or anything. It certainly came from that direction. But yeah, oh, always good fun. Times like this, I wish I did have a manual. Okay, well, I'll put these 2 in, and we'll just see what happens. So I thought I'd test the motor, and it's fine. Looking at the current, I mean, obviously not great. If we can actually get it to show on camera. The refresh rate's a bit weird. There we go. So yeah, and it's actually fine both ways as well. I mean, this is actually driving for a lace, and it's fine. Now, this motor is the same as used on a C9 lacing motor, so I will compare that in case it is drawing more current than it should. But so far, I mean, I can't see any real problem with it. That sort of swarthy stuff on there is a bit interesting, but yeah, so I'll have a look at that and compare notes. Yeah, so scrub that. The Sony motor is actually drawing about sort of 78-80 milliamps, and the other one was only drawing 3 milliamps. I don't quite understand that, but it's running and it's got torque. So tested the motor and the NEC both ways as well, just in case there was something weird going on in the one direction, and it's fine. So yeah, still not quite sure what's going on there, all a bit weird. So next I'm going to check the motor, and it's not going to be easy if I can just get in there. There's a grub screw. I don't quite see that. There's a grub screw on the top of the motor, so I know I've done a full revolution. Oh. Straight away, 2 ohms that's going down to. I'm getting a very good contact there. Let's just come back. Yeah, there seems to be an area where I'm getting like 4 ohms, 2.2 ohms. One of those, it's like it's short. There should be 17.5 for each little bit. And then there, I'm getting a short. Or near short. Okay, so it's looking like that motor is a bit dodgy. Now I do have somewhere a motor assembly from a C9. And I think that motor is the same motor, minus the board on the back, of course. Now, I do need this pulley off for possibly for SL1700, SLO1700, which is split. It's one we actually looked at in a previous video, and I noticed it was a bit sluggish and a bit weird, and it's got a split down the cog. And these are actually quite difficult to glue or do much with because they're it's doped. It's doped with carbon. So yeah, I'm just going to replace it, and job will be a good one. So yeah, let's get and do that next. Well, I've just checked it, and what I actually did is I put glue all sort of on the top of the gear. The pulley, and that has actually done the trick. I've sort of brought it up and over onto the metal as well, and run it on the actual shaft of the motor. It does struggle a bit, and that's actually absolutely fine. So okay, well, I'll just gently pull this off, and I seem to remember you do have to get a screwdriver under the centre of it just to pry it off. Hopefully I won't split it. So yeah, because I'll keep this. So obviously starting to fail. But yeah, that's all good. So it's actually very useful to have. There is actually a very small split in it, which I might have actually done. But anyway, so yeah, so this can go now. That was the only thing that's needed, and playback picture's really good. So yeah, really chuffed with that. So yeah, let's crack on. So I got the tape out, which was a bit interesting, and I did try and wind the spools as well. I was the one spool that I could see that I was winding. Try and save the tape, but yeah, I actually managed to not damage it just by being very careful. So that was something. So let's get this motor out. Never done this before. So this will be fun, and I am looking to be a little bit creative how I do this. Now I do have an SL1000 service manual, so I could refer to that, but I am just going to wing it because I'm probably daft. There is a cable tie there that may have to go. In fact, I'm pretty certain it will. Oh gosh, that's tight. Oh gosh, they're both tight. You can feel the heads actually. Wow. I might have to scrape away the glue. Gosh, they're tight. They are so tight. They are really, really tight. And it may well be that the varnish is just adding so much more mechanical strength. I could feel the heads almost of the screws just like shearing off almost. Oh, this is not good. Oh, that cracked. Oh, that was lucky. So luckily I can move it, which might just free it up a bit if there's enough. Oh gosh, there's not much left. Come on. That's really annoying. There's not much left of that. I can get anything. I mean, what can I do?
6.5 hours later.
Good grief, I got it out. It's like just a blinking miracle. I tried all sorts of different screwdrivers, and I actually took the camera mount down thinking, I'm just going to leave it for now and just think about it tomorrow when maybe, yeah, I'll come up with some bright idea. And I thought, well, I'll take off the head amp and the mains unit, the mains filter PCB, which is always good fun. It gives me an opportunity to dust this out as well. And just to get some more access to this. And I actually used a couple of, or a pair of, I actually used a pair of plumber's grips, and held what I could get of the screw really, really tight, and turned, and it cracked. I heard it sort of click, and then I used my electrician's screwdriver, which is the only screwdriver that seemed to still get some sort of purchase on it, and managed to get it out. And it is the same story as the other one. It's not actually as bad, to be fair, but there is varnish on the top of the thread, and oh blimey, I mean, honestly, what a pain in the neck. Makes it nice and easy to get out though. But yeah, so that's it. Motor's out. And we can change that and see how bad these screws are, I suppose. But yeah, let's crack on. Well, we have a new motor, or a replacement motor. But it's not the motor I was hoping to use. The motor I was hoping to use was this one, which is the lacing motor from the C9. And this is actually a different voltage. There's no part number on these. And to be fair, they're relatively cheap and cheerful motors, but having said that, they're well made, and they don't do much. I say they don't do much. They don't run for long. So, you know, they're fit for purpose. But this also had the problem, I'm glad it didn't fit this actually, the bearing wanted to fall out from this side, which was not ideal. Yeah, I can't make it do it now, but I was pushing that in and it's floating about quite loosely, and these will fall out sometimes as well. So yeah, but this I think is a different voltage to the one that's fitted for the lacing on the NEC. So, but the carriage one is pretty much the same. I'm noticing when I put the meter across this, the resistance of the coils is a little bit higher, just slightly, but there's no shorts. So I do wonder what's happened to this motor, or indeed whether it's even faulty at all. But this one I know is good. I took it off a front loading system from a C9 that I know the motor works, but it's missing a gear off there, and I can use this for parts. So it's no biggie. There's no loss, and I probably will put this motor with it, with a note on it just to say that it could be dodgy in this situation. Yeah, well, I might just bin it. Because it's not worth the risk. Yeah, because if I'm going to get this going, probably, I don't know. I'll probably just get rid of this because I can't trust it. I just don't want to trust it with a short, potential short on it. So yes, yeah, rambling on. So this one I will put in this back in the spares bin, and we'll address that bearing as and when we need to. I mean, I do wonder if they are supposed to be able to move in there. You can always set the motor up, but I've probably damaged it now doing that. Anyway, so I have replaced the two middle green, what are they? 2SB772 transistors in the middle there. So there's two brand new ones there, and I've replaced the whatever it is, the 975 2SD975 as well. So that's all good. So we've got yeah, we've got all new transistors now, and yeah, 2SD985. So hopefully this will work. This is really weird because the old ones measured like diodes, and the new one measures as a proper transistor, so I don't know what's going on there. But anyway, I suppose time to put it back together. Can't believe what a pain in the neck it was to get that motor out with that varnish, but yeah, let's crack on. so it's all or nothing. I'm going to go for it. I'll put a cassette in, and I think we're on. Yeah, that's on. So, as soon as I power it up, it'll either lace or it'll go up and smoke. And I'm actually going to do this from the other room because I just don't want to see it do it. It's just like, yeah, I just hope to have some good news when I come back into the room. It breaks my heart when chips smoke like that. Okay, let's crack on. Oh, did anything happen? Oh, okay. Let's give that another go. Nothing's hot. Just wondering if it doesn't like the motor. Take the belt off. Let's just see if I put that up there. See if it does actually turn. Well, it's certainly sounding good. Oh, I just don't plug it in properly up here. Anyway, so it's powering the motor. Just wondering if this belt's maybe not quite the right size. Let me just see if I can find a slightly looser belt. Well, I've put the old belt back on. I couldn't find one that was sort of looser, but it's not that tight. So I've just wound it on a bit more, and let's just power it on again and just see what happens. I've got no clock either, which is a bit concerning. That's running cool enough. I wonder if I've got the wrong voltage motor. It's trying, but it's just not working. I don't know what's wrong with this clock. That's a bit concerning. Yeah, I've not got anything on the clock. Oh, that's annoying. So I need to try and find. The thing is, I don't know what voltage the. Okay, so quite a bit's happened since the last segment. I have put the old motor back in. I've compared the two motors. They do seem about the same, to be honest. But it is a bit weird that the replacement motor, it just doesn't seem to have the same amount of torque as the original motor. It draws about the same current, but it's much easier to stop this motor than it is to stop that one. So there must be a difference there. Well, there is, because on the resistance readings, this was about 20 ohms per winding. That one was more like 17. So very slight difference. I think there's very little in it, but it's obviously enough. So I've not put the belt on, and I'm going to power this up, and we shall see what happens. So let's plug it in. So it must have just been a bad driver transistor. and the Darlington. I wonder which went first. How bizarre. Let's put the belt on and give it a test. So let's power it on again and see what's happening with the clock. The clock comes on and it goes off. I think there's probably more contamination. I wonder if it's it has actually damaged the variable cap. But let's try this. Same thing. And it's loose enough. What on earth is going on? It's just not enough to actually drive. The lacing. I mean, I could adjust it, but do I need to adjust it? It's a little bit further. Didn't show you any of that, did I? A little bit further out. No. Just have no drive. Why? Why is there no drive? I mean, maybe I have a 12 volt. But then there's 12 volts on there. This is really bizarre. So probably that other motor was okay for the application, but might have been a bit slower, but it would have done the job. But how weird, how really weird. I mean, is the clock a clue? Are we maybe? Because I've measured that. Oh, I've measured it with the belt off and the motor revolving, and I got 12 volts. But is the 12 volt rail being pulled down somehow? Questions, and no answers. Let's crack on. We do have another issue. I did give it a test the other day, and yes, I'm going to replicate that now. So let's eject it. So screwdriver in this assembly here, if it'll focus. Let's push that forward. If this is laced in any way, shape or form, even just slightly, you can't do that. It's actually locked. So let's put the cassette in. It's not powered on. I'm going to wind this on by hand. I have a new replacement transistor on the way for that one there, which was not from Little Diode and was quite a bit cheaper on eBay, and it is faulty. Well, I say it's faulty. I don't think it's actually what it says on the device. It is, so that'll be why it's not driving things properly. That's the theory anyway. I'm going to do a comparison when the other one arrives. I suppose I could remove the good one that I bought from Little Diode, because I did the lot in the end. So yeah, all good fun. That's it, we're laced. So let's power it on. Let's see how the clock's going to behave tonight. Oh, it's staying on. Fair play. That's something. Still not terribly convinced what's going on. I do wonder if the actual oscillator is damaged from the battery leakage, but we'll cross that bridge when we get to it. So let me just connect some leads and we'll see what happens. Okay, so let's turn it on. Hopefully it shouldn't unlace. No. Okay, cool. So let's press play. That's slightly different to what I was getting the other night. So we are fully laced. Shut down. So you can see what's happening with the heads. Yeah. So let's press play. And that's as good as it gets. I mean, it's actually worse than when I tested it the other night. So it looks like we have a problem with the capacitors on the servo board. It's probably going to be the you can see one there actually, light blue Sanyo caps. It's locked up again. All gone into failsafe. So yeah, we need to change those and hopefully that'll be something else fixed. Let's crack on. So I think I had the luxury of being able to very easily remove this board, which would be quite nice actually, because when you put these on their side to work on them, this is the best side to sort of put it on, they are still very precarious. So I'd quite like to take the board off really, but all the connectors do look unique, which is great. So yeah, let's get that removed. Of course, it's not quite that straightforward. There is actually an earth or grounding wire there, so yeah, whip that off with the soldering iron. I took the baseboard out and realised I'd had a C7 moment. The servo section is not on here, and I know this because I've been working on the board. Because it's the same board that has the lacing unlacing drive transistors on it. So yeah, I don't even know why I took this out, except it's a really good opportunity to give it a jolly good clean, which I have done. Some of these caps look a little bit... well, just like the sleeves haven't been put on very well, to be fair, but yeah, they're all Rubicon capacitors, or majority of them are anyway. So, and I have just had a look over the board to see if there's any leakage, physical leakage, any signs of like anything out the base of them, and they're all fine. So that's really cool. But it's nice just to give it a jolly good clean. But yeah, it's just amazing how the design of it and the look of it is just so similar to a C7. So there's a C7 one. And yeah, you can really just see the similarity. I mean, it's amazing actually just how similar they are at first glance, but of course there's no servo. And yeah, I just thought it was quite interesting to see. I mean, that's a lot more sort of spread out, I suppose. But yeah, so I am going to put this that board back in, and we'll have a look at that servo board. I'm debating how best to do that because, in theory, well, you'll see. Let's crack on. Well, looking at the board, I thought the head drum power switching, whatever, is being controlled by this board. This is the Syscon board. It's actually really cool because there's very few capacitors on there. And yes, I was thinking the head drum is being started and run from this board, and it's not at all. It's actually being controlled from there, from the MDPWB, which I'm guessing is motor drum power board. And what threw me as well, Sony I think they use brown, red, orange, and this is blue, black, red. So red is probably power, black's probably ground, and blue is the feedback for the servo. I can't see where that is, where that goes to. I think it goes to the bottom board, maybe. But yeah, I haven't got a circuit diagram, so I'm sort of guessing really. I think it might be on that connector, maybe. Oh no, that's the Capstan. There. So there's Capstan drive there, because I thought that was Capstan, but it isn't. So Capstan's driven off there as well, and then the drum's driven off there. That's like the driver, power driver for it. There's only one cap on that board, and I wonder sort of what's going on really. It's not making a lot of sense. Quite a few transistors that could have gone a bit leaky maybe. But yeah, I'd sort of like to know where the servo comes in. Maybe it's that one. There's a blue wire there which suggests maybe that is servo feedback. Yeah, I think that's probably the next thing to do. I'll put this board back in. I did change these two caps for what it's worth. They tested absolutely fine, but they're the only ones that I would be a little bit suspect of. The rest of these are like 1 microfarad, 50 volts. I think there's a 4.7 there somewhere as well. Oh, there's a 10 microfarad there. 1, 1, 1, and there's 1, and I think that's a 1 as well, so maybe no 4.7s on this one at all. Yeah, 1. So they're all 1s apart from that one, which is a 10, and then these two are 100 microfarads at 25 volts. I've fitted 100 microfarads at 35 volts. As you know, that's fine to do. But they were the only ones that I was a little bit like, well, while I'm in there, I will just change them. You know, the bottoms looked okay, relatively, so probably a waste of time. But yeah, I've changed that. Slightly different package. There's no metal on the back of it. It's bare metal for a heatsink on this one, but it is a bit thicker. Hopefully that will work. Won't go up in smoke. And yeah, I suppose we can get it back together. Oh yeah, and this is fixed as well, so that's cool. Hit some heat shrink on it, extended the wire, trimmed it back, extended the wire with a component leg actually, and it's solid core, but it'll be fine. And yeah, that should be okay. It's just trying to reduce the strain in the future. This board has been in and out a lot. I mean, that was the other thing. I mean, this board has had a lot of repairs in the past. Some of them I think might be just bad joints, just resoldering, but this chip has been changed, and these here have been changed. It's a bit of a clumsy repair there. So that actually on that. Interesting. So mill looks fairly good. The soldering, something gone on there as well. But yeah, somebody's struggled with this before, and I wonder if that's what blew this in the end, to be honest. Just fiddling about with it, maybe it touched here. I think that's just a bit of flux splatter, but yeah, anyway, like I say, let's get it back together. Some more evidence that the whole board's been out at some point is the cabling. It's actually a bit of a faff. I took the counter belt off. There's loads of space there with the front cover, the front panel removed, to get in there. Give that a clean as well, that'd be good. Yeah, fed the cables through. It's a bit of a faff. But this was pushed right the way out the way, and they really have put a pretty hefty cable management bit of metal, sleeved metal there, to make sure that this doesn't actually foul the counter. So yeah, that's actually quite cool. I do now need to get these cables behind here and around here and connected back up. These are both the same types, so that one's, I marked that one with a Sharpie. By length, they sort of guide their way there, but I was being careful this time. I'm usually, yeah, maybe a little bit too trusting in these things, that they're all going to be unique, and this one I decided to not be. So yes, I'll give this a clean. Feed these wires, they have to go behind the plastic here and through. Some clips as well, but I'll clean all that, get it back together, and I suppose give it a test. At least we can test the lacing, and maybe stick the meters and well, the meter and the oscilloscope on that as well. Let's crack on. After a few days of doing other things, because this thing's taking forever, I'm back on the NEC, and I actually used a C7 bottom board just to work out what chip did what. And basically, there's nothing on the bottom board to do with servo. It's all video processing, audio, chroma. This is head drum, so access it from the top, having taken off the tuner unit, which I will show being put back in. I didn't show taking it apart because I just wanted to crack on with it actually while I had a few minutes to do it. What I have done is I've pretty much replaced all of the electrolytics. Now, I did test all of them, and they all were pretty much okay, to be fair, with the exception of this one. I think it's 1000 microfarad at 16 volts. They're all Rubicon, so they're good capacitors. I mean, let me know in the comments what your experience of them at this age has been, but I tend to find Rubicons are amongst the best, really. There is a bipolar cap in there, which I think is 100 microfarads, quite a large value, 16 volts, which is a Panasonic National capacitor, but that actually checked okay. I was a bit dubious whether that might be, it's the purple sleeved ones, because they can be troublesome, but that's the only one. It had leaked, which you can't really see now, but you can a little bit shiny there. It had leaked, and it lost about a third of its value, and the ESR was quite sky high, so I'm hoping that's all it is. Capstan board, driver board, that actually looks okay. Caps on there look okay. I have a vague recollection reading somewhere with these that the tantalum capacitors can be troublesome on them. So if we do have problems, I would suspect it's probably one of those. Yeah, it's just odd how the head drum motors just sort of starts up and then just grinds to a halt. So yeah, I'm going to power it up now, and yeah, we'll give it a try. I believe if it's anything like the other machines of this age, it's perfectly fine to leave sort of the tuner RF, all the rest of it, out and run it like this. So yeah, we should be good to go. So yeah, let's power it on. So probably can't see it, but we have got clock problems still, which is great. So we've got a different problem now. Right, so we've got no feedback on the head drum, but this is not just grinding to a halt like it was before. So yeah, let's crack on. The fun continues. So I've changed all the tantalums. I have to say it's the higher capacity caps that seem to be the ones that are the worst. I even found two that were just completely open circuit. They were just completely open. So I've replaced them all, blanket change. These ones here, these are 1.5s. So I haven't got that value. So what I've done is put a 1 and a 0.47 across it in parallel, just to make it somewhere near. We'll see how that goes. Now, I did have a look at PalSykes. I think I mentioned earlier, there was mention of the tantalums going bad on these machines, and it was on about a 2.2 microfarad. And it's just like, well, I've gone through all of these, and none of them are 2.2. But I thought, well, if they're bad on the capstan, the head motor, they're going to be bad on the capstan servo. So I'm going to change all of these, and indeed, I think these two are 2.2, and there's a couple of others as well. But it does seem to be the slightly higher values. Anything above a 1 seems to be dodgy. But I'm going to change them all. There isn't that many. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's all these dark blue tantalums. But yeah, it's a bit of a pain. It's interesting as well, the electrolytics are just so proud of the board, but visual inspection, they all seem okay. and to be honest, at this stage I'm just quite happy to run with it and see how we go. They probably will be okay, but yeah, let's change the tants and take it from there. So yeah, let's crack on. Well, that was fun. I changed all of the tantalums, and there's actually a couple of 10 microfarad and 4.7, and they were actually open, totally bad. 2.2 was really weird ESR and reading, actually reading high, but the smaller ones were all fine. So yeah, it does seem anything above 1 and above on the tantalums is probably going to be dodgy on these. And yeah, interesting. So I suppose we ought to try and get this back together and give it a test. Let's get this back together. Well, back together, so I suppose I want to give it a try. I don't know why I'm quite nervous about doing this, but anyway. Usual clock issue. Yeah, we still have a head problem. Don't do that too long. Yeah, so we still have head problems. The clock's still playing up. Oh, this is not an easy machine. But at least it's not running fast. Yeah, so we still have Capstan. Sorry, head drum issues. Yeah, we're now in shutdown safety mode. Yeah, I was so hopeful. I just thought that would really make the difference. you obviously have other issues, so yeah, I suppose you ought to have a look at those. Let's crack on. Just for the fun of it, let's try eject. And lace, will it catch fire? Yeah, we've still got problems lacing. Don't believe this. It's just one thing after another, isn't it? I'm trying not to electrocute myself as I do this. Oh, I think we... Timed out. I just don't know what's going on there. I do wonder if that one transistor that I changed is actually dodgy, like it's a copy. Because the unlace is fine. Oh. How far do I go with this machine? I don't know. I just think that, I mean, I will get it going. I will get this going. I've gone so far with this machine and I've learned a lot. I mean, it's been a great learning experience, but my goodness. I really have to move on, I think, and come back to this machine at another point. So I think I am going to say thank you very much for watching. I hope you enjoyed this incredibly long video with no actual happy ending, which I was really hoping for, to be honest. But I mean, if you have a manual for one of these, please let me know, and maybe we can do something. Maybe I can purchase it from you, or yeah, borrow it, whatever. A PVC-700 manual would probably do the trick. I don't think there's an awful lot of difference between the two different machines, 740 and the 700. But yeah, it's just such a pain that I just can't properly diagnose it. I mean, like I say, I can reverse engineer from the Sony chip data and the C7 manual. The head drum, I mean, I'm assuming the capstan is rotating. If I can just lace this up. So we're laced up. I have to rewind a little bit. God, that's horrible. I just don't want to damage the chips. I mean, it's not so bad on the thicker head disc. It's not so liable to break a head chip off, but I still don't like doing it. Nah. So frustrating. So yeah, there will be a part 2 at some point in the distant future, because I've got so many other machines to do. And yeah, so I hope you enjoyed this one and learned a little bit about these machines. There's very little about them anywhere really that I've found, so going a bit more in depth with this. And I mean, I've put so many capacitors in this machine with all the power supply ones, the servo side of it, obviously those motor load, the lacing control. I'm just gonna have to try and sort something out with those. I just think I've got a bad copy there, but yeah, so with that, thank you very much for watching, and a like and subscribe would be very much appreciated. And I know it's a bit sort of raw and crazy what happens on this channel. It is just documenting me fixing these things and enjoying doing it. I hope you enjoy it too. And yeah, it is what it is, just fixing these machines and trying to give them as much life as possible for people to enjoy them, do their copies of videos from back in the day, and even have the odd movie night. So with that, thank you very much for watching, and hopefully I'll see you in another video. Bye for now.